My name is Markus. I'm a web developer for more than 10 years now already. I'm also a researcher and W3C invited expert, so that means I'm doing also a fair bit of standardization work these days. And today I'm going to show you how you can build next generation web APIs with JSON-LD and Hydra, so better web APIs, simply speaking. The reason why you probably want to do that is because I think we are now at the stage where we have been with websites roughly 10 years ago. In the early 2000s, it kind of became obvious that businesses have to have websites. So you didn't have to convince companies anymore to build them a website, they asked you. And the same is now becoming true for web APIs. It's kind of obvious that at least bigger companies offer you access to their internal data via a web API, and consumers increasingly start to expect that. And also developers start to expect that because they want to build applications on top of that data, so they want to integrate different applications to build value-added mashups, other applications. So that's of course great. I mean, we as developers have now unprecedented access to data. We also have unprecedented access to functionality, so we can build applications which previously would have been just too expensive to build. So we can leverage functionality like complex algorithms somewhere in the Google Cloud or some other functionality which, well, would have been unfeasible to develop for a small software shop, for example. The problem, however, is that using those web APIs is still very challenging. So by challenging, I don't mean that it's challenging to access a single web API. That's quite trivial these days. You just do a couple of HTTP requests. But it quickly becomes very difficult to do so if you are going to access dozens or even hundreds of different web APIs, because then you have to go read documentation about that web API, figure out how to build your HTTP requests, how to process the data that you get back, and you have to do that over and over again. So it's a very boring task because they all look very similar, but there are still minor little details that are different in every single web API. So you can't build a generic client, but you have to adapt it to every single web API. So you either write that yourself or you download an SDK for that web API and just use that. But also that it's not a very good approach, because then you have a huge code base that you have to maintain, and the quality of those SDKs, they vary wildly. So some are buggy, some fail at some times, and so that's not very a good approach. So if you think back how that all started, roughly a decade ago, the first approach to bring data on the web were those now infamous WS star services, so those SOAP-based services. And they were actually quite convenient, because you as a developer, you just wrote your code, then you fired up a tool, and that tool created a WSDL file, which is nothing else than a description of your functions, your method, your classes. And you just published that WSDL file somewhere, and then a client could go fetch that WSDL file, again, run a tool, and that tool then created the local counterpart of your API. So you got some nice classes where you can invoke methods, functions, and they then invoked the HTTP requests for you. And all that was done completely automatically. So you didn't have to, well, know much about it, and it just worked. Well, at least sometimes it did. The problem with that approach, however, was that the approach by itself is completely flawed. So it tries to hide all the differences between local and remote computing, and that's of course very problematic, because if you invoke a function which runs remotely, that function will be much slower, and it can fail in ways that a local function, for example, just can't. So you can have partial failures, or things like really long timeouts, so you run into timeouts, and it's very difficult to recover from those errors. And of course, those automatic code generation tool sets, they sometimes also run into interoperability problems, and that's the reason why I think there are, I don't know, 40 or 50 specifications just describing how those systems are intended to work together, but still in practice they often fail to do so. So the main reason why that approach didn't work, even though it was so convenient, was that it kind of broke with all the aspects of the architecture of the World Wide Web. So it was completely alien to the web. It kind of tried to do RPC on the web, but that didn't really work out. So it abused HTTP, for example, as a transport protocol, which means that every request was an HTTP post, and of course you can't cache posts, so it doesn't really scale, or it doesn't scale at all. So in the years after that, the developers or the community started to, well, see that there was something wrong with that approach, and they started to improve their web API. So they started to embrace the web as the architecture of the web. So they started to use different URLs for different things. That's level 1 here. That's, by the way, Richardson's maturity model. Doesn't really matter. It's just a nice way to show how web APIs got better over time. And then they also started to use the HTTP verbs correctly. So that's level 2 in his model. And that already gives you a lot of advantages. So you can cache things. You can use gets to get data. You use different URLs for that, so you can cache it. So it really scales well. And that's more or less the state where we are now. So if you look at a simple example, and that's an example which I will use more or less throughout my talk. So let's assume we have an issue tracker. And that issue tracker exposes a web API. So let's, well, just GitHub, for example. So if we now go and dereference the URL which identifies an issue in that system, what we typically get back is a JSON document these days. And that JSON document would probably look something like the one shown in the slide. So you have an identifier and some properties and some data. And that's how most web APIs look these days. However, there are a couple of problems with that approach as well. And that's the billion-dollar question. So what's wrong with that approach? Well, if we go back to the example, the thing here is that in order to interact with that API, or even to understand what the data is about, you have to, again, go read the documentation, figure it out, and then hard-code your client against that. So somewhere in that documentation, you will, for example, find a URI template, which describes how you can get the comments associated to that issue. And since you hardcode the client, then the hardcode can use the ID up there, for example, and expand, resolve that URI template, and then finally you can go and fetch those comments. But of course, whenever the URL changes, your client will break because it can't adapt. It doesn't understand the documentation. So you as developer hardcode that in your client. So that's not very flexible. And the problem here is that these responses don't use hypermedia at all. So hypermedia is one of REST's constraints. And actually, it has been made very clear from the very beginning of the web. That's the first website, the very first website that got restored just a couple of weeks ago because the web has its 20th birthday as an open platform. So even that very first website made it clear in the first sentence that the web is a hypermedia system. That means that responses should include hyperlinks, hypermedia controls directly. So simply speaking, that means your response should include the hyperlink so that your client can just follow that hyperlink. Here I use a relative URL, but it doesn't really matter. It can also be an absolute URL, of course. And since the term REST was so often misused, even though it includes that hypermedia constraint, nowadays the term hypermedia API is used when talking about web APIs that do use hypermedia. So going back to Richardson's maturity model, that's now level 3. And that's, according to Richardson at least, which brings you to the full glory of REST. So according to him, if you are on level 3, so if you use different URLs for different things, if you use the HTTP verbs correctly, and you include hypermedia, then you're fully RESTful. Problem with that model, however, is that it's a bit misleading. So that kind of gives the impression that there are levels of restfulness, but that's not true. In reality, only level 3 is restful. So all the other levels are, by definition, not restful at all. So you can't call a web API which doesn't use the hypermedia or doesn't use different URLs for different things a REST API. And there is another aspect missing in that model, and that's a very important aspect, I think. So if you go back to the example, if you look at that, I mean, for you as a human, it's kind of obvious what that data means, or that, yeah, how you can interpret it, how you can process it. But even if you just look at the comments property, for example, it's not that obvious that it is a hyperlink. Of course, again, for you, it's kind of understandable, but the machine wouldn't be able to figure that out. So the data by itself, in this case, doesn't mean anything. It's not self-descriptive. So you can't even build a simple client which, like a crawler, for example, which does nothing else than following all the hyperlinks, and that's why I put up that billion-dollar question. So Google, for example, did just that. They built a simple crawler which follows all the links. They analyzed that link structure and made billions out of that. But you can't do that with such an approach, because that data doesn't mean anything. So it's not about the properties, the text, that doesn't mean anything, but even the document itself doesn't mean anything. So in HTML, of course, also the text in there doesn't mean anything to a machine, but the tags, like the anchor tags, paragraph, and all those things, they still mean something. They have some very well-defined semantics, which allow a browser to, well, render the document. So, and that's exactly the problem which makes every web API a snowflake. So every web API is kind of unique these days. And you have to go read the documentation to figure out what it is all about, how you can interpret the data, in order to, again, hard-code your client against that information so that you can finally process that data. And of course, that results in tightly coupled systems. So whenever your server implementation changes even just slightly, your client will break. So that coupling is really brittle. And if you interact with lots of web APIs, that becomes very problematic, because most of the time you're just, well, running behind and trying to fix things which break all the time. So just to make that very clear, that's again the response we got back from our web API, but the machine would just see something like that. So for the machine, it's just some binary data. And it can understand that it's a JSON object, and it sees that there are 6 properties, but neither the properties nor the values mean anything to the machine. So what we need to do to, well, fix that problem is we need to make the data unambiguous. We need to give it some semantics. We need to make it kind of understandable to the machine, at least to a certain degree. And that then makes the response self-descriptive, so it makes the API self-descriptive. So in a sense, what we need here is we need some kind of unique identifiers for those properties, like we have anchor tags, all those tags in HTML, for example, which a machine can then recognize, so that you can implement much smarter clients, or at least clients that are able to do something automatically. And if we think about that, I mean, on the web, there is one thing that is used all over the place for identifiers, and that's URLs, or URIs, so Uniform Resource Identifiers. They are globally valid, they are unambiguous. If you have a domain name, you can make them up yourself, so it's completely decentralized. And, well, you can use them for whatever you want. If you own the domain name, if you own the URI, you can decide what it's intended to mean. And if you use URLs, so if you make those URIs dereferenceable, we can actually build a system which allows you to follow those identifiers to get the meaning of the identifier. So to kind of have a documentation which you can look up. So it's not like a primary key in a database where you have to know what it means, but you can just put that in your browser address bar, follow it, and you will get back the description of it. And that's something that's called linked data. So that's unfortunately not something I've invented, but something that Tim Berners-Lee invented. So Tim Berners-Lee is the inventor of the World Wide Web, as I'm sure you all know. And just to give you kind of the official definition, here are the 4 principles. So he said that you should URIs for everything. So for your properties, to identify your entities, so not primary keys, but full URLs for that as well. You should use HTTP URLs to do so, or HTTPS, doesn't matter. The thing is that you can use them to look up the definition of them. So if you run across a URI, an identifier which you don't know, you just put it in your browser and you look it up. And of course, if you own that URL, you should return some useful data, some useful information about that URL if someone does go and look it up. And finally, you should also, of course, include links to other data. So just as in HTML pages, I mean, you will rarely find a HTML page, for example, which doesn't include links to some other pages. And the same should be done for web APIs as well. So the problem has been till now that there wasn't really a format which allowed you to do so. So there was, of course, XML with those XML namespaces. They are also just URLs, but that's not very flexible, and you know, XML is not really used that much anymore in practice. And it's also very restricting because if you had like 3 different namespaces and then you used them, you had to use exactly the same terms in your XML document then, which often, well, it just didn't look good because some people used, you know, different capitalization or stuff, so it wasn't really nice. But that changed recently. Sorry. So there is now a new format. It's called JSON-LD, and that format allows you to do those things, so to use URLs for everything in quite a simple way. It's, as the name suggests, a JSON-based syntax to express linked data. We started as a community for it roughly 3 years ago now, but we brought it into the W3C, and it's now in last call there, which means that it will become a proper standard in a month or 2. It is, of course, 100% compatible with JSON, so that means you can reuse all your JSON tools. You don't have to change much. You can keep your workflow. It's more or less as simple as JSON, but at the same time, it is very expressive. So it, in contrast to JSON, which serializes trees, it allows you to have hyperlinks as well, which means that you serialize graphs. So you have different entities and they link to each other, so you end up having a graph. Okay, so, well, the basic idea behind JSON-LD is to make the data unambiguous by mapping everything, so properties, identifiers, basically everything to URLs. And that then gives your data a explicit semantics, so an explicit meaning. So I think it becomes a bit easier if we look at a simple example. So in this case, we have a JSON document which serializes some information about the person, about myself. It uses an identifier that's just like a primary key in a database, and it's the first name, last name, and the home page. So to make that linked data, to convert it to JSON-LD, what you would do is you add a context. The context is, in principle, nothing else than a lookup table. So you map a property to a URL, and that then makes your property really unambiguous. It gives the property a meaning which you can reuse across different web APIs. So if you have 2 different web APIs and they both use schema.org, which is a vocabulary which was developed by Google, Bing, Yandex, and Yahoo, and they use it for markup, to mark up things in HTML pages for search engine optimization, so those rich snippets that you've probably seen. Then if you use that across web APIs, you will recognize that that's the same property, so you can much more easily integrate data, for example. And of course, since we now described all our properties with URLs, it would just make sense to do the same for the identifier as well. So we do just that. JSON-LD that's done by the @id keyword. So JSON-LD uses all keywords in JSON-LD start with an @sign, but you can alias them to something else. So you can change that to whatever you want. It's exactly the same. So you just define a mapping in the context. You say, I don't know, identifier maps to @id. So you can really control how your JSON should look like. The only problem now that's left is the homepage properties. So in this case, it's still just a string. But as we've seen already, entities can be identified with URLs with the @id keyword. So the simplest thing to do would be to just wrap that into an object and add an @id property. And then you have a hyperlink between two entities via the homepage relation. Of course, that doesn't look really nice if you don't have other properties associated to the homepage. So you could, of course, include things like the date when it was last modified or the title, for example. But if you don't need that, then it would be much more beautiful if you just have a string there. And you can actually do that in JSON-LD as well. So you can just extend the context a bit. You define the type of the property, say that it's of type @id, and then you can serialize it again as a simple string. The last thing that you will often want to do probably is to specify the type of an entity explicitly. So in this case here, you can, of course, easily infer that, well, if something has a first name and a last name, it's probably a person. But if there wouldn't be the first name and the last name, but just the homepage, for example, then it wouldn't be so unambiguous. So it could either be a company or a person or, well, some other organization, for example. But we can make that explicit as well. So we just add an @type and specify the type with, again, a URL. In this case, we use schema.org person. And if someone doesn't know what that means, well, he can just put that URL in his browser and look it up. Then he would get back that definition here. So that's the official page, and like I told you before, all the major search engines support that kind of data. So in a sense, you don't even have to document that stuff yourself anymore. You just use the URLs, and then, well, it's already documented. So it saves you a lot of work as well, and it brings you a lot of benefits in terms of interoperability with other APIs. The only thing that's probably not as nice now is that the document got almost twice as long. So you have a big context, and you have your data, and the context will look, well, exactly the same in almost all responses that are speaking about a person. So what you typically do is you take that context, put it in a separate file, just as you do with CSS files, and you just include a link to that context instead. And then we again end up with a nice, simple JSON document, which looks almost the same as the one we started with. And especially if you consider that you can change the keywords. So who uses JSON-LD? As I told you, it's not really a ratified standard yet, but it will be soon. But there are already quite a couple of early adopters. And maybe you've used it already. So if you use the Symfony content management framework, for example, that uses JSON-LD. So if you change a page in the CMF, the data will get serialized in JSON-LD and then sent back to the server. Other early adopters are, for example, well, that's the stack which is used by the Symfony CMF. That was a research project by the European Union. The BBC uses it, for example, in all their internal APIs. And as I've been told, they will be opened up in the next months. So as soon as the standard becomes ratified, they will also publicly announce their support for it, because those big players typically don't do that if the standard is, well, not ratified yet. Google uses it. They announced it last week at the Google I/O. So you can now embed JSON-LD data in your emails, for example, and they will extract that data. They will show you some simple buttons, for example. If you embed things like an event invitation, they will parse that data and then show you a button so that you can, well, say, well, I'm coming or I'm declining the invitation without leaving Gmail at all. or you can add things to your calendar or to your address book. But yeah, there are actually quite a lot of other early adopters, which I don't have the time to talk about them, all of them. So the Digital Public Library of America, for example, also uses it in their API. But, well, let's go back to the main topic, building web APIs. So as I told you, JSON-LD is a serialization format, and by itself, it doesn't really have any semantics. So it doesn't define any of those URLs. In the examples before, we used schema.org for that. And that really defines concepts from a broad range of application domains. But unfortunately, APIs are not, there are no concepts for APIs yet. And that's where Hydra comes into play. So Hydra is a small, really small vocabulary which defines the URLs that you will need to describe a web API. So it defines various concepts, and you can just use them as we used schema.org before to describe your web API in a machine-readable form. So let's again use our issue tracker example. So we already have a hypermedia API in this case, but it's not really hypermedia because the client can't see the link. So the first thing we'll do, we'll convert it to JSON-LD so that we add a context to it, which tells the machine already, well, the value of comments, for example, that's a URL. So you could follow that link. But just following a link is not very interesting. So we could also describe that we not only are able to follow that link to get the comments, but we would also like to use it to add a new comment, for example. And since the comments URL, the comments property is now identified with a URL, we can of course use a URL which we control. And then we can just put a JSON-LD document at that location and describe in that JSON-LD document how you can use the comments property or the value of the comments property. So let's look at that document. It's quite simple, actually. So we have the comments property in there. I use a hash URL, but that doesn't really matter. It's just if you use hash URLs, you can include a lot of things in one document, so you don't have to do a different HTTP request for everything. It's like in HTML, those anchor tags. And it's a Hydra link, so that's just an abbreviated URL, so the Hydra URL for the link concept. And it also describes a number of supported operations. In this case, we have just one, and that's the one to create a new comment. It's of type Hydra create resource operation, which means that if that operation gets invoked, a new resource gets created. In this case, it's an example, a comment. It also has some documentation for the developers, a natural language description of it. It specifies the HTTP method that the client has to use, and also the data the server expects from the client and the data it returns on success. So that's a class. It's very similar to a class in your programming language. So we can look that up as well. It's also described in JSON-LD. It's just somewhere further down in the document, again using a hash URL. It's Hydra class, as I told you, and it also has a number of supported properties. So in this case, again, we have just one. It's a text property, so the content of the comment, and that property is required in this case, which means in order to send a valid request to the server, the client has to include that property. It's marked as not being read-only or write-only, so read-only would mean that you can get that information from the server, but you can't change it, and write-only means you can't get any information, but you can change it. So for example, passwords. You can't retrieve them, but you can change them by sending a new password. And that really describes your API in a completely machine-readable way, which allows you then to build much smarter clients. But of course, it's a lot of work to write those documents. So I think quite a few of you already think, well, there must be a bundle for that. And yes, there exists a bundle for that. It's called Hydra bundle. I know, a very creative name. So it's very similar to how Doctrine, for example, works. So you would just need to go and annotate your entities with a couple of annotations. So the first thing you'll do is you mark the entities that you're going to expose by your web API with a Hydra expose annotation. And that then creates that block of JSON-LD, which I showed you before, and also automatically generates a URL for that, so an ambiguous URL, unique URL. You can, of course, pass a parameter if you want to specify that URL yourself, or you can also specify a full URL if you want to map it, for example, to schema.org. Exactly the same is done for properties of that class. So the comments property here, that's also exposed. But in this case, it's not only that we expose that property, but we also define it as a collection. So in this case, the comments property holds an array of comments. And typically, you don't include that directly into your response, but you just include the link to get those comments. So we say it's a Hydra collection, and we pass a route to it. And that route is then used to create the full URL of it for the collection. So that when you go and dereference that thing, you will get back JSON-LD document, which does contain all the comments. And the same mechanism is used to add the operations. So again, it's a route, and that route then maps to some controller method. The nice thing now is that since we have all the annotations, like we have more or less all the information we need already, we can create our controllers completely automatically. So it's exactly the same as the Sensio generator bundle. You just specify the entity you're going to create a CRUD controller for. You specify a route prefix, and then your controller gets created completely automatically. The controller doesn't really look any different from your existing controllers. It's just a class with some methods. And again, you have to mark which ones are going to be exposed. And that's done by a Hydra operation annotation in this case. Here we have an expect parameter, which defines what kind of data that controller method expects. We could, of course, extract that from the method signature, but, well, just didn't have the time to do that yet. But for example, it extracts the @return value from the doc block already, or the title of that doc block, so you don't have to specify that as a parameter. And that then really creates all that JSON-LD description for you completely automatically. But, I mean, why should you do that? There must be a reason for that. Otherwise, it doesn't make sense to do all that work. So there is actually a really nice benefit if you do so. And that's that you can build completely generic clients. So you can build one client, and you can reuse it for all web APIs that are going to be described by Hydra. And just as kind of a proof of concept, we created something which is called Hydra Console. It's an API console. So it's a single-page web application. It renders your response alongside the complete documentation. So it's really self-descriptive, even for you as a developer. I mean, as a human, you can just go read it. If you move the mouse over a property, you will see the full URL. You probably don't see it, but it also highlights the according property in the documentation. All the links are recognized as links. So in this case, we have relative URLs, so there is no regular expression or something going on here. It's really recognized as a link. Of course, you can click it, follow the link. But in this case, we have some operations associated to that link. So if we click on it, we get a popover, which shows us all the operations that are available. In this case, we have 2. You can, of course, also invoke the other HTTP operations, but they are not documented, so we don't know what happens if we do so. But we can, for example, post something to create a comment. If we do that, we again get the documentation about what's going to happen. And the client is also able to render a nice, simple form completely automatically, so you don't have to do anything here. And then you can type in your comment, just click on invoke, and that's it. So that really makes makes it much easier to build web APIs, to test them without having to write a client yourself. You have a generic client. So in a sense, it's like a web browser, but a web browser for web APIs. OK, so that's it from me. If you're interested in that stuff, you can look it up on my homepage. You will find the complete specification of Hydra there, also links to JSON-LD, of course. The API console is there, the complete source code. I also started work on a little PHP client library for that, but it's not ready yet, so don't download that. Of course, also the Symfony 2 bundle is up there, so you can reuse that. OK, thank you very much for your attention. So if you have any questions, the slides they should be now posted at my Twitter thing, so you'll find the slides there if the API call didn't fail. And if you have any questions. Is there
any relationship between JSON-LD and HAL JSON? Or how do you compare that?
So the question was if there is a relationship between JSON-LD and HAL JSON. No, there is no relationship. They're kind of doing similar things, like both of them are trying to include hyperlinks in JSON, but HAL stops there. So in HAL, you can HAL is kind of an envelope where you can put some links on there, but you can't, for example, describe what a property means in HAL. Whereas JSON-LD goes a step further and allows you also to specify the type of an entity or what a property means and those kind of things.
That's not using the API part of it, right? It's just using the format to store content on the whatever content repository, or is it actually reading those properties and schemas and doing things with it?
So the question is how the Symfony CMF is using JSON-LD and how it's using that kind of stuff. There is another technology which is called RDFA. So that's the technology that you will use to include that data in your HTML pages, for example, to get those rich snippets. So in the Symfony CMF, if you go look at a website in your CMF, you will get that website and it's annotated with RDFA. So it really maps the data to the same URLs that you use in JSON-LD. And if you click on the edit button there, then it will turn your HTML page into a form, basically, so that you can edit the stuff. And if you click on, well, submit, then it serializes exactly the same data using the same URLs in JSON-LD and sends it back to the server. So it kind of extracts the data from the HTML and then serializes in JSON-LD and sends it back to the server.
I'm reminded of one of the talks yesterday talking about the Guzzle language and also Swagger. Is the hope that JSON-LD kind of becomes when it is verified or ratified, that it becomes the de facto standard way of describing a RESTful API?
Yeah, of course, the hope is that. But no, I think the approach is quite different because with Guzzle's service descriptions and Swagger, it's still, you kind of hard code your client against that, whereas here you interpret that at runtime. So you get your data back, and then the client can look up what the data means, like while he's retrieving the data. So it's much more adaptive and flexible, and yeah, so I think the approach is really different. So Guzzle and Swagger is more like those SOAP-based services in a sense, because you create your client statically, kind of.
Does this increase the amount of actual requests required? You just load the data and you have to figure out what it is?
Yes, of course, you have more HTTP requests, but as I showed you in the example, for example, you can use those hash URLs, so you just do one request to get all the properties, and of course you can cache that information. So you do it once and you reuse that for, I don't know, well, the cache header will tell you how long you can reuse that. And I don't think that's a really big overhead. But yeah, you're right, there are more HTTP requests, but the same is true in HTML pages. For example, you also load your CSS file. So that's not really a big deal, and it's more or less static, so you can cache it quite well. That shouldn't change that often. Any other questions? Yeah.
So are there like best practices emerging about how to use the schema, or like say I want to extend a person, do I extend it or do I just clone it and make my changes and go through locally?
There is a mailing list if you really want to extend schema.org. So of course you can't do that on your own because you have to get consensus about the extensions. But since everything is a URL, you can, of course, just make up your own URL, define what it means, describe it, and if people start using it, you can, of course, use it yourself. And if other people use it, that's also fine because it's globally valid. I mean, it's a globally valid identifier. So it's completely decentralized, the model by itself. But of course, it makes sense to reuse something which is widely used, such as schema.org, because then you can reuse code across different things much more easily than making up your own identifiers for everything. I think there was a question in the back.
Can you talk a little more on the client side that are necessary?
So the changes necessary in the client side. Sorry, what was the last thing? Okay, so, well, on the client, you of course have to be able to interpret that as JSON-LD. You can, of course, also just use it as JSON, but then you don't get any of the advantages of it. So there are JSON-LD processors in PHP available. And the difference here is that you don't really couple to a specific JSON structure anymore, but you couple to some URLs. You couple to some concepts, simply speaking. So you couple to the meaning of the data, and the meaning of the data typically doesn't change very often. So your JSON structures change sometimes because new properties get introduced, and then it makes sense to rename some of the properties in order to have kind of a consistent representation. But the meaning by itself doesn't really change often. So a comment will still remain a comment in the next couple of years, probably. It's not going to change. So it's much, it's much more, it's at a higher level of abstraction, simply speaking, and that makes it much more stable.
Are there tools on the client side that kind of help digest it? Being like a mobile phone app trying to access APIs,
What kind of tools are you thinking about, generally? There are JSON-LD processors, like in almost all major languages available already. And they, for example, allow you to, that's something called framing. So you kind of specify like a template, and that then transforms your JSON-LD into a specific structure. And then you can, again, work with that just as with JSON. But the thing is that you don't depend on the structure on the server side, but you define the structure you're expecting, and the JSON-LD processor transforms that at runtime to exactly what you would like to have. Okay, thank you very much again.